Welcome to another episode of the AI in Manufacturing podcast here on Industry 4.TV. I'm your host, Kudzai Manditereza, and today we will discuss building and scaling closed-loop AI for manufacturing operations. My guest on this episode is Dr. Nikita Kolovko, who is a software architect for industrial AI at Siemens. Nikita, welcome to the show.
Yeah.
Glad
Hi,
to have
hello,
you on.
Kudzai. Yeah, thank you. So maybe shortly let me introduce myself. So as you already said, my name is Nikita, and currently I'm working in the Siemens as a solution portfolio architect. I have approximately 16 years of experience in software design, process design in scalable, secure, cost-effective software architectures for industrial and different business critical use cases. So I have a PhD in artificial intelligence. It's about how to bring AI solutions to the methodology. Yeah, maybe it's very shortly about myself. Nice to meet you, and thanks for your invite.
Yeah, absolutely. Certainly looking forward to really unpacking this, topic with you. Yeah, so it's kind of like really I mentioned we're going to be talking about, this idea of, methodologies for
Mhm.
building and scaling closed loop AI in industrial environments. But let's kind of like start with the bigger picture here to set the context
Mhm.
for our audience here. So from your perspective, why is closed loop AI so critical for modern manufacturing operations? And maybe you could highlight some risks
Mhm.
to manufacturers that sort of like delay this approach.
Yeah, sure. So, from my perspective, currently we have rapidly evolving industrial landscape, changing processes, and nowadays AI becomes not an option but must to have for each and every company who would like to stay competitive on the market. And especially it's relevant for our UA market, where we have a high pressure from Asian competitors, and we need to still provide a high quality of our production, need to be quick, need to stay competitive, and need to reduce our costs and our uh, efforts how to produce this new stuff. And currently AI became something far away from academic, from research perspective, because we have has a high maturity of AI technologies, high availability of hardware. Currently, we have hardware rather cheap and rather fast. From the perspective of AI technologies, we already passed this peak of AI hype, and we see, especially when we consider this bringing AI to the shop floor, we think that these two words of IT and OT becomes closer. These two spheres start to talk on the same language, and it means that AI becomes not something which processes in a big data centers, but something which we can already bring to the shop floor. Maybe just to summarize, I see AI as a crucial point for improvement of each and every business, especially for factory automation, because we need to improve quality, we need to improve speed, but to stay competitive. And otherwise, yeah, we will be any kind of company will be out of market without AI.
Yeah, absolutely. I mean, that makes a lot of sense, and
Mhm.
I'm also, excited to hear you, talk about this example that I always, give people whenever I talk about the agency of AI adoption, to say that if
Mhm.
if European companies are really hard to compete with with their Asian counterparts, you can't overstate the importance of being able to really adopt these technologies that help manufacturers be more agile, super efficient. And so that's why I think it really resonates very well, with me, your assessment there.
Yeah, exactly. And let's say to decrease this level of dependency from human factor and just to be quick, to be competitive. Yes.
Oh yeah, absolutely. So maybe let's kind of like, to ground this discussion here, I want to get your sense on when we talk about specifically, when we're talking about AI on the shop floor, or rather
Hmm.
closed loop AI, I want to
Hmm.
kind of like get your sense on how do you define a closed loop AI system in the industrial, context, and
Hmm.
then maybe talk to us about what are the, tangible business outcomes, if implemented correctly.
Mhm. Yeah, exactly. So, from the perspective, what does it really mean, closed loop AI? It's a little bit far away from classical AI when we have models which just predict something or do some kind of stuff. It's more about constantly collecting data from machines, from sensors, analyze this data, analyze what is happening in real time, watch how well AI models is performing or behaving, and try to identify model drift, maybe when model loses its accuracy, and based on this information to trigger retraining process and to have this loop and, let's say, some kind of independency from human impact. So from this perspective, model can work independently based on data which it receives from the shop floor. And talking about real business effect, of course it's a reduce of downtime, because we better utilize our business assets. We have few production interruptions. Of course, here we can see a high improve of quality, fast response to changes, because if something happens on the shop floor, our closed loop AI model can quickly adapt to this changing conditions. Uh, with the help of AI and closed loop AI, we can decrease operational costs on the shop floor. And of course, through this prism, we can speak about more accurate and precise forecasting and planning for business or for any kind of plans and or any kind of production business lines.
Yeah.
Of course, it's fair to any kind of, let's say, AI use cases, but in the case of classical AI, we have at the end of the day human in the loop who make decision, who need to retrain, who need to collect, and who need to act, and he and or maybe she, this man in the middle, it's a bottleneck for this closed loop interaction, embedding of AI to the shop floor, to the production.
Yeah. And I guess this is kind of like the point that I wanted to sort of like, bring to your
Hmm.
attention here, to say what sort of like, maturity, AI maturity indications should companies look out for, or rather strive to reach, as far as closed loop AI is concerned. Because as you may know, in kind of like some companies, they don't really uh, receptive of this idea that you can actually let an AI make
Hmm.
decisions that can actually be fed back into a control system. In your view, how what are the requirements, maybe to put it simply, should companies put in place to sort of like make it
Hmm.
that AI trustable or trustworthy to be able to be in a closed loop system?
In any case, what I talked before, it does not really even means that it's mandatory to fully rely on AI and to give AI all ways how to operate your business. Uh, uh, Even with closed loop AI approach, you can use AI as some kind of assistant. So the main advantage that AI work on the shop floor, work on some kind of end condition, receive data, and based on this continuous data loop, make some kind of recommendation, some kind of I don't know, prediction. And even this scheme can be used for any kind of business, for even for business who cannot rely on AI, just as an assistant. So you can embed, implement this scheme, stay next to your production line, just watch from customer perspective, from the operator perspective, what kind of recommendations this model gives to you, and it's up to operator whether to apply this recommendation or not, and maybe step by step, just maybe partly applying this recommendation. Business at the end of the day can see that, okay, it makes sense to rely on a concrete use case and a concrete, I don't know, specific product case on AI recommendation. So it's just continuous process of building this trust between human and the AI, and just step by step applying, or maybe some kind of giving even feedback to this AI solution, how good their prediction or not.
Awesome. So, I mean, you mentioned the issue of data, right? So effectively, you have data pipelines where you're collecting data from your production equipment to be able to train the AI models. So as you may know, these issues currently as far as the data accessibility to be able to train AI models. Can you speak to us, in your view, what you see as being like the kinds of fragmentations that are preventing the development of these closed loop AI system?
Yeah, mainly as you already mentioned, the biggest problem is data. It's a fragmentation and incomplete of data, lack of reliable data source from which data can be collected, how data can be consistently and in a secured way delivered to the upper floor where data should be aggregated, to, I don't know, to build some kind of data layer. So first biggest problem is the data, how to collect data, how to bring data to the same format, how to make this data representable, how to make the process of data delivery, data collection in a continuous way, and how to build this data knowledge. It's the first big problem which stop any kind of AI solution, AI innovation. The second big problem is delay in a retraining process. Again, this problem is also because of data, because models which are currently trained somewhere in the cloud or outside shop floor, they need to rely on data, and since data is outdated, they don't represent the real picture on the shop floor. Models are often retrained or trained on some kind of outdated data, and this very rarely updated. Again, another problem connected with data, with training, it's a lack of strategies when and how models should be retrained, based on which parameters, based on which metrics. Another problem, it's not even about AI, it's about, let's say, any kind of data, any kind of building teams. It's unclear ownership and who is responsible at the end of the day for data, for retraining, for each step in this model pipeline, who's responsible for deploying, who's responsible for monitoring. It's more or less organizational problems. And of course, again, about data problem, it's insufficient data to represent all possible states of your machine, all possible states of your process, because currently, and it's not a secret, we have to work in some kind of limited data sets, data sources, which are only represent not the full state, not the full possible variance, how you aggregate, how your process can behave. And it's also sometimes a problem, because we can judge, we can make a hypothesis only about, I don't know, limited use case, but we cannot extrapolate this to a wide number of products. But yeah, if to summarize, the biggest problem is data, how to collect and how to build reliable data layer for a future AI researchers.
Yeah, maybe let's kind of like talk about solutions to this data problem. So you mentioned this lack of uh, like not enough data is
Mhm.
collected with the right context. The data is often delayed, for retraining of models, and then the lack of
Mhm.
strategy and things like that. What sort of like approaches have you seen to, or do you recommend that work best in sort of like eliminating these data challenges?
Maybe first idea which came to my mind and maybe recommendation, it totally makes sense to collect all data from the shop floor, because nobody knows which data you can use, which data will be available for your concrete business or AI use case or not. So to collect data, to maybe have some kind of uh, uh, middle layer storage for your data, maybe somewhere on the mass level, maybe somewhere on a factory level, just to collect, maybe to some extent have this so-called data lake in a smaller size, but nevertheless just to collect data. uh, Based on this middle layer data lake, you can also use some kind of AI algorithms to find some kind of similarities, I don't know, consequences, dependencies in this data in order to create first hypothesis. So first of all, collect data, try to standardize your data, try to make this data collection job in a usual as a usual job. Mm, and then maybe think about how to deliver this data to the cloud, to the upper level. But it's difficult to provide some kind of silver bullet recommendation. But what I propose, it totally makes sense to collect data and have just to define who is responsible for each data source, for reliability of this data source, for maintenance of this data source, to create this so-called data strategy in order to create this data layer. Because at the end of the day, any kind of decision, and not even AI, should based on this data, and it's difficult even to talk about any kind of even management decision if you don't have enough data, if you don't know how to check your hypothesis, if you cannot create your knowledge. Everything it's data based.
Yeah. And I think that kind of like brings me to the next question here, which you have really already alluded to, this divide or friction between sort of like shop floor or factory floor data users, and also your central IT or data scientist users.
Mhm.
So in your view, what kind of like is, maybe first of all, can you explain to our audience why there is that friction between your automation engineering aspect and then central IT, and then maybe talk to us about what would be a more effective strategy of sort of like closing that gap between these two domains.
In any case, it's a classical, how to say, it's a classical issue between IT and IT, mainly come from previous history. And the main problem, because IT guys and OT guys, OT, it's automation guys, they are solving different problems. They're responsible for different tasks and different problems. And first of all, the biggest challenge between these two worlds, it's a language. But currently we are going into the direction when these guys start to talk to only one language. But the next big challenge is the security, because as I already said, for instance, we have a data lake on OT level where we collect all data. But the biggest question, how transfer this data in a secure way from OT level, from factory level, which is often not connected with internet, or maybe limited connected with internet, to some kind of IT systems, which are in the most cases somewhere in the cloud. So security, so a lot of works, a lot of problems are around security. Uh, what else? So the biggest problem, because they're responsible, they saw even the same problem from different angles. Because for automation guys, it's important to maintain production line, to keep things working. But from IT perspective, they are just speaking from the perspective of IT systems, how to maintain this IT system or another system. So IT systems cannot be mapped to IT world. That's why we have this range of miscommunication, misunderstanding between these two worlds. But currently, technical progress helps us to bring them to the same page, and maybe you even heard about bringing PLC to the cloud, but
Yeah, and I mean, maybe kind of like, to linger more on that, aspect of it. How then do you, empower? Because the situation, in most, especially enterprise companies, is that only the data scientists, are empowered to leverage
Mhm,
AI, right? So because they are the one who've got the tools to implement AI solutions, analytics, some tools that may not be easy to use for ordinary factory users or subject
mhm,
matter experts, control engineers, process engineers.
mhm.
How do you, because in any case, what you want to do is you invest in data or AI, you want to be able to empower everyone across your organization to be able to leverage AI. So
Exactly.
how
Mhm.
do you do that? What do you recommend as far as that is
So
concerned?
it's a good question, because currently I see a big gap, not even between IT and IT, but the biggest gap when we speak about AI is still between data scientists and domain experts. And from my perspective, when we talk about AI, first of all, we should talk to domain experts, not to the data scientists, because at the end of the day, we are through this AI, through each instrument, through each approach, we're trying to solve pain and tasks of domain experts who are responsible for a producer, for a providing products, for a reaching KPIs. And here we have a very funny and very hard situation when we have a lot of very smart guys from domain experts who knows a lot about processes, but they're far away from data science world, and we need to fulfill this gap. And from my perspective, uh, let's say in a general sense, we should try to bring domain experts as close as possible to data, to these AI tools. uh, One of maybe idea, since we have this generative AI, since we have this rather cool uh, additional layers on top of LLMs, on top of already existing AI tools, we can use this approach to help domain experts to build maybe ugly but nevertheless first models, try to check their hypothesis. Because at the end of the day, what we need to do, we just need to provide domain experts some kind of tools through which they can check their hypothesis. For instance, the main expert has a number of images and he's interested, okay, uh, uh, what kind of correlations these images has. Or maybe I have a hypothesis that temperature affect the level of defects on my products. Okay, I need some tool to check this hypothesis. It means that we need to try to first of all reuse already existing so-called data science sugar, like LLMs, ChatGPT, try to help domain experts to build this hypothesis, and with this hypothesis they can came to data scientists and say, hey guys, we just check this and this and this. For us it looks that this hypothesis makes sense, it's valid, let's check it together. And in this case they will already try to speak on the same language, because currently they again speaking and living in two different worlds. It's the first. And second one, maybe something from my previous experience, it's more democratic approach when we create a common environment where data scientists can work together with domain experts. For instance, data scientists can uh, upload some kind of pre-trained model to this environment, and domain experts can also work in this environment, see already existing models, try to map these models to their domain problem, maybe try to test these models with their images and make decisions. So through collaboration, through bringing both of them to common environment, maybe through enabling for domain experts some kind of data science tools, we can improve this collaboration and maybe make this better.
Yeah. And then maybe I want to kind of like get a bit of some, clarification there on that approach. Are you so basically your recommendation is it that domain experts be able to also train their own models, or rather just train, use models that have already been built?
It's two approaches. First approach is it's much easier to create this environment where domain experts can use already existing pre-built models from data scientists. I would say it's great for big companies where they have a separate data scientist department and so on. And the second approach for a small companies or maybe for self-motivated domain experts is try to use this LLM approach. Of course, it's maybe dangerous to give my personal, not personal, but data from my production line to this ChatGPT bot. But in any case, maybe if some companies can afford to create their own bot, I don't know, Llama or something else, just to use these LLMs, these NLP embeddings, just to provide, just to make this interpreter between domain experts and this assembly of AI models.
I see. That makes a lot of sense. That makes a lot of sense. So is it more towards I think maybe the term is this idea of AI agents that domain experts could use to sort of like speak to the underlying
Yeah.
classical ML model,
Yeah,
right?
yeah, yeah, exactly. So to create this language interpreter between some kind of low-level AI models and domain experts, just to make this, make this more transparent and
Awesome. And then
interpretable.
yeah, thank you. So and then I kind of like want to take a step back also, before we proceed and talk about this idea of data collection. So I also want to get your opinion on this idea where normally, or companies, what they do. So we spoke about this idea that companies need to standardize the data and then sort of like store it into some shop floor data store. And so the challenge with other approaches is that as companies sort of like push data into a data lake or cloud warehouse, a lot of data scientists who don't have the domain expertise, they don't know the structure of the data, they often struggle to contextualize the data so that it can be useful, and insights can be extracted so much faster. And do you sort of like, and you spoke about this idea of data ownership. In your view, what is the role? Do you believe this role of data contextualization and normalization should be done at the edge or should be done centrally? What's your opinion on that?
In any case, first of all, it does not depend, let's say, where we will work with this data on the cloud level or maybe in the edge. We first of all need to define who is owning this data, who is responsible for this data, and maybe first of all through this soft responsibility, we need try to enrich this data with the knowledge. Because again, very interesting fact, I already faced it. I know a lot of smart domain experts guys who need this instrument of data augmentation for data labeling in order to share their knowledge with their colleagues. That's why, first of all, as I already said, we need to create this data layer. It does not matter where this data layer will be, on the shop floor, on the cloud. It's some kind of data storage where data can be collected. They can be annotated by domain experts. Based on this annotation, we can create, or we can talk about some kind of knowledge. This knowledge can be shared, and based on this knowledge, first of all, management decision can be made, and second, some kind of data hypothesis, AI hypothesis, AI models can be built. And in this case, once this data was commented and augmented by domain expert, any kind of models becomes more or less interpretable for them if we build this model on top of their data. But it's let's say it's easy to talk about this, because in the practice it works in a much more sophisticated way when we face data, because data is always a chaos.
Awesome. Yeah, maybe to kind of like make this all concrete for our audience, could you walk us through your reference architecture for this closed loop AI system? What does that typically look like?
Yeah. So as I already said, this journey, this architecture can be built from two even opposite point of view. First, it's from point of view of data collection, how data should be collected, how data should be stored, streamed to the upper level. And second point, it's from the perspective when model was created. It's from cloud perspective. But nevertheless, from my perspective, I will highlight maybe several main pillars of this architecture. First of all, I see that it should be SDK block, some kind of block which will help data scientists to package their model in a respective format which can be inferenced on the shop floor. Maybe some kind of extension of Python SDK, since all data scientists are work with a Python. Also, this block should be extendable and embeddable to CI/CD pipeline. It should support all possible ML frameworks, PyTorch, TensorFlow, TensorRT. And at the end of the day, it's a way how data scientists will package their model, because from data scientist perspective, it's just necessary to care about how to create model, how to package, and the rest work should be done by other colleagues. So the second layer, the second components, it's a component which should be responsible for model distribution and for model management, for so-called fleet management function, which will be also responsible for deploying this model received from the upper level to the separate inference runtimes, inference stages placed on the shop floor. And also I see for this component, for this layer functionality, for a retriggering, retraining process and identifying model drift. The third one, maybe the most important, it's some kind of inference engine which should work on the shop floor. This inference engine should be responsible for model inferencing and also support GPU. And as a part of this data journey, it should be a component responsible for data collection, for instance, for time series data collection. And also this component should be responsible for vision use cases data collection. And of course, if we speak about visual use cases, we should have some kind of component which will abstract our interaction with cameras, maybe some kind of, I don't know, vision connector. And Also, it makes sense for this component which is responsible for data collection to have some kind of rules based on which data should be sent to the cloud. This data should be aggregated. This data should be sent in some kind of secured way, for instance, with the help of MTLS. And yeah, maybe it's. I suppose later after our podcast, I can share maybe 2 of my drafts with a reference architecture, and yeah, we can share with audience and with your colleagues
Yeah.
something in a graphical form.
Oh yeah, absolutely. Yeah, we'll definitely share the graphical layout of the architecture. So maybe just a few questions here on that. So you kind of like mentioned also the idea of model retraining.
Mhm.
So I wanted to get a sense on how do you typically determine when a model needs to be retrained? What's the sort of like indicator there? Is it model drift? If so, how do you measure it, and how do you sort of like track it?
For instance, it can be model drift because as a part of model deployed to the shop floor, which is inferenced on the shop floor, we can also implement mechanism of providing model metrics. We can retrigger based on this metrics when we see a decrease of performance, decrease of accuracy. It's a first approach. Second approach, when, for instance, we have some kind of so-called gold model somewhere on the model manager level, or maybe in the cloud level, when we compare with the cloud metrics, and based on this comparison between real model and gold model, we can also retrigger retraining process. Some kind of generic recipes, but of course we can also include a human in this loop in order to make and to give his opinion about concrete model output. But yeah.
Okay, perfect. And then the other issue is the issue of sort of like the communication middleware. I want to get your sense on
Mhm.
what do you see as the most commonly used. So, for example, you've got your models that are performing inference. They
Mhm.
need to exchange these insights either with control systems, or maybe push it back into the cloud. That communication infrastructure for closed loop AI systems, what do you see a lot of companies using for that layer?
It's difficult to talk about, let's say, edge level, because each and every company use some kind of uh, layers and levels provided by different providers. For instance, from Siemens side, we have an edge ecosystem. I know that another automation companies has also edge ecosystem. It depends. But from my perspective, first of all, when every customer talk about AI on the shop floor, as I already said, this customer should think about data, how to collect data, how to make this data consistent, and it's not even mandatory to use some kind of specific ecosystems on the shop floor to provide this. First of all, these exercises, experiments can be done by customer by himself, just to collect, just to understand what is happening on the shop floor. And after this, if customer would like to scale this, he can think about some kind of edge ecosystems. It's what about shop floor part. But on the side, on another side, I currently see that when we speak about data science part, mainly cloud providers are used. So it's Azure, so it's AWS. I would say it's a majority of cases. Sometimes I saw Databricks It also depends on level of data science maturity of a specific company, but from my perspective, cloud providers are rather good for making a data scientists life easier.
All right, great stuff. All right, now moving on. I want to touch on one other interesting, so sort of like comment that you made in some of your content.
Hmm.
This idea that sometimes this isolated AI wins can
Hmm.
negatively impact across the value chain. So this idea that you've got customers that are working on a pilot AI and then it
Hmm.
works successfully on one
Hmm.
line that kind of like has got some negative consequences. Could you maybe expand on that? Tell us a bit more about what your thinking is around there.
Yeah, sure. So yes, it touches another level of complexity when AI becomes a part of the whole business strategy, of the whole strategy of the company. And for example, it's not even about AI on the shop floor. In this case, you need to take into consideration what kind of effects, what kind of impact our models has to the whole business, to the whole business line, to the whole production line. For instance, we have some kind of model which is optimized for a production. It increase a number of production items we are delivering per minute, per time. And from the local perspective, this optimization looks okay, but from the perspective of whole business, it can bring a lot of problems because, for instance, warehouse will not be ready to store such huge amount of production items. Suppliers will not be ready to provide us sufficient materials to provide a production. So it means that this optimization isolated from the whole business strategy, business value is always an evil for a business. And from this perspective, maybe it totally makes sense to talk about some kind of approaches, frameworks, or maybe engines through which business or maybe manufacturers can validate uh, AI ideas and not even AI ideas. So some kind of approach with the help of which uh, we can implement this innovation in our production life. So, for instance, it can be a separate respective group of engineers who is responsible for collecting paints from the shop floor, what current problems are, how end customers see the solution of these problems. Then, as a separate work stream, we can create some kind of not a digital twin, because digital twin is a bad term, some kind of model of our end business value with the help, I don't know, for instance, with the Celonis, and have this hypothesis and this model of our business process, so we can see the real impacts, which effects do we have, and based on this we can make decision whether it makes sense to implement one or another model on, or which it will affect on.
Awesome. Yeah, so I mean, a big, part of our audience here is, manufacturing leaders who, sort of like are looking to, come up with strategies for, implementing this and also being able to prove ROI for these, implementations. And I would like you to talk to us about your innovation validation engine, which is basically sort of like
Mhm.
a mechanism that allows these digital manufacturing leaders to sort of like how do they pick the idea and sort of like how do they continuously track the ROI on that implementation. Could you maybe unpack that for us?
Yeah, sure. First of all, let's say a question of ROI is first question we faced when we came with any kind of optimization, with any kind of AI models when we came to business. And frankly speaking, it's rather difficult to answer this question. And sometimes we need to, I don't know, invent some kind of synthetic and sophisticated metrics. But as I already said, uh, we can become a little bit more close to this ROI evaluation if we will build this framework, if we will build this pipeline of idea validation. So engineers who collect ideas from the shop floor without any kind of judgment, just to collect as a brainstorm, collect these ideas. On another hand, we build this end value chain model of our business with the help of Celonis. We define all points of data collection, from which points data should be collected, how data should be collected, who is responsible for this data to create this data layer. And having all these, we can implement so-called data strategy, AI strategy, where we will put all this information, how hypothesis collected, which kind of data based these hypotheses are based on, model our process and see impact, what is changing, what is not.
Yeah. And generally speaking, what sort of like advice do you have for like manufacturing leaders who are listening to this conversation right now, and then they want to get started with shop floor AI implementation? How should they think about getting started and approaching this problem?
Yeah, first of all, I suppose, as I already said many times, start with data. Try to organize the way how data is collected. Try to organize the way how data is storing. Then try to build on top of this data knowledge. Try to summarize domain experts' knowledge on top of this data, because even having this data, any kind of business will have a lot of additional insights about things which are happening on the shop floor, which they need to optimize. Having this data layer, business needs to start to build hypotheses on top of this data, and even without AI, try to validate these hypotheses through this business framework, through this validation framework. Then make an environment where data scientists, where automation engineers and domain experts can collaborate and share their knowledge, and maybe to empower, maybe to motivate them to collaborate in this environment. And then as a last step, build models, and then go some kind of technical ways how to build model, how to deliver this model to the shop floor. But data is crucial, data knowledge.
Oh yeah, 100%. Totally agreed on that one. All right. So to conclude this discussion, so I always ask our guests to come on here to give us, not so much a prediction, but a sense of where do you see, AI going in the next, few years. What's the future of AI in industrial or shop floor, in your perspective?
In any case, I believe that AI has a great potential in changing industry, in helping us to improve performance, to improve quality. But main idea from my side, we need to stay engineers. We need to stay careful with AI. We should not use this hype which is currently happening around LLMs and so on, just to be engineers, to be smart, uh, to be curious, and try to apply new technologies to our everyday's life. But I still believe, and I saw this high big change of AI role in industry for at least 5-10 years.
Awesome stuff. Yeah. So, I mean, that brings us to the end of this session. So, as we already mentioned, we're going to provide links to the reference architecture that we spoke
Yeah,
about.
exactly.
So, maybe before we close this share session, is there anything that you want to say to our audience? Any interesting projects you're working on? Where can they find you? Just anything you want to say?
the audience can find me in the LinkedIn, so I feel free to contact me. I will be happy to contact with everybody and to share my knowledge, and maybe to, I don't know, to get something new from people's outside around me. But unfortunately, I cannot talk about my projects.
Yes.
But thanks a lot for inviting me. Thanks a lot for your time, and we'll be happy to stay in touch. And if you have any questions or maybe interesting ideas you would like to share or maybe to communicate, yeah, feel free, and I will be happy.
Absolutely. Thank you.